So I'm going to be presenting some work that our lab has been doing for the better part of a year now, looking at prosodic phrasing in speech production. So to start off, I just wanted to give a broad overview of what prosody is and why we really care about it. So prosody broadly refers to the acoustic elements of spoken language that vary independently of the lexical items or the words we're actually saying. And so when we look at measuring the specific aspects of prosody, typically what we're looking at are variations in pitch, variation in the durations of individual words, phonemes, or syllables, the pauses that we insert in speech, and specifically where we pause and how long we pause for, as well as the intensity or energy of specific words, which includes things like the volume at which we're speaking. But prosody is a lot more than just the acoustic signal of speech, but it also is used to link together multiple levels of linguistic representation. So for instance, we can use prosody to convey semantic information, such as putting more emphasis or prominence towards specific words to change the meaning of sentences. We can also use aspects of prosody, such as pitch contours, to distinguish between the types of sentences we're using, such as declarative statements or questions. We can use prosody to convey emotional or pragmatic intent. And finally, we can use prosody to mark the end of syntactic phrases. And this final point is specifically what we're interested in this project, is looking at the alignment of prosodic phrasing and syntactic structure in spoken language. So on a very traditional or strict view of the relationship between prosody and syntax, it's often assumed that prosodic phrasing comes from the syntactic structure. So for instance, given this sentence, as Jim knows, Mary became a psychologist, we have two syntactic clauses, as Jim knows, and Mary became a psychologist. And on this traditional view, we would create two prosodic phrases based on those, as Jim knows, Mary became a psychologist. And so the implication there is that when we have the end of a syntactic clause in spoken language, it should be marked by the end of a prosodic phrase boundary. But this entailment doesn't necessarily go the other way. So it's not the case that if there's the end of a syntactic phrase, there should also be the end, if there's the end of a prosodic phrase, it doesn't necessarily mean there'd be the end of a syntactic phrase. And this is because, as I said before, prosody links together multiple levels of linguistic representation, but it's also influenced by non-linguistic factors, such as the limits of our working memory capacity, or just the physical need to breathe and pause to breathe as we're speaking. But nevertheless, a common assumption in the psycholinguistic literature is that listeners can use prosodic cues to infer syntactic structure. So as we're comprehending, if the end of a syntactic phrase is prosodically marked, it can facilitate parsing of the sentence. And this has been shown in many papers throughout the field, that listeners do capitalize on these prosodic cues to assist with syntactic parsing. And so part of the challenge with this is that if we know that during language comprehension we use these prosodic cues, it kind of hinges on the idea that this is actually how speakers talk, and that speakers do actually use prosody to mark the end of syntactic phrases. But one of the challenges in the literature on production is a lot of the evidence we have comes from studies that have speakers come into the lab and read pre-written sentences or pre-written script, which offloads a bit of the planning because they don't have to sort of spontaneously generate what they're going to say. But it also is possible that people are approaching this task saying sentences how they think it should be said rather than how they would say it when they're just naturally producing speech spontaneously. So this is where our research goals really come in, is we wanted to take a look at what the relationship between prosodic phrasing and syntactic structure looks like in spontaneous, unscripted spoken language. And the main starting point for our work on this comes from a paper by Giulio Degano and colleagues that looked at how prosodic markings and syntactic boundaries facilitate processing and specifically syntactic parsing during language comprehension. And so their goal wasn't necessarily to look at the alignment of prosodic and syntactic structure, but in order to identify cases where they lined up to see if it facilitated syntactic parsing, they had to first identify prosodic and syntactic boundaries in speech. And what they showed looked something like this, where they identified all of the prosodic and syntactic boundaries across 4 different TED Talk speeches. And in this figure here from their paper, it's on the x-axis here, it's grouped by strong and weak prosodic boundaries. And the solid bars represent words that don't reflect a syntactic phrase boundary, where the dashed lines or striped bars represent words that do have a syntactic phrase boundary. And what we were particularly drawn to was this section of the graph here that shows that when there's not a strong prosodic phrase boundary, there's still about 44% of those words that represent a syntactic boundary, which seems to suggest that in these speeches, there's a lot of misalignment between syntactic and prosodic phrasing. And so our goal in our research was to take the methods that they use to identify syntactic and prosodic boundaries and apply it to our own data. So I'll just walk through the methods that they used and then get into the research that we've done. So the first step is to identify the prosodic boundaries in the speeches. And they did this using something called the Wavelet Prosodic Toolkit, which takes in a WAV file and a corresponding text grid. And then for each word, calculates various measures of prosody, such as the pitch, duration, or energy of each word, and gives back something like this, where for every word in the speech, you get the onset and offset time to get the duration of the word, and then it calculates, or takes in those prosodic features to calculate prosodic boundary strength for every word in the speech stream. And then to determine which words represent a strong prosodic boundary, a weak prosodic boundary, they used a density function to model the whole range of prosodic boundaries across all of the speeches, and then extracted two latent distributions to cluster words or boundary strengths into strong versus weak, and then calculated a specific cutoff to kind of binarize prosodic boundaries. So the cutoff represents approximately where the two latent distributions overlap. So everything in the yellow, every value in the yellow would be considered a strong prosodic boundary, and every value in the kind of gray would be considered a weak prosodic boundary. And then to identify syntactic or closing phrase boundaries in the speeches, they used this BASI pre-trained pipeline with the Berkeley neural parser, which is a dependency parser that takes in a transcription of the speech and gives back a parse of all of the text. So the output looks something like this, where this is just from a sentence, the first sentence of one of the TED Talks. And as you can see, after each word, it gives the number of kind of closing phrase nodes, where every word gets at least one to represent a word boundary, and everything beyond that was identified as a syntactic boundary. And taken together, we can create this figure here that shows the relationship between where syntactic and prosodic boundaries align and where they don't. And as I said before, based on this part of the graph, it seems to suggest there are a lot of places where boundaries don't align. But one of the challenges, again, with their work is one, it wasn't specifically designed to look at the relationship between syntactic and prosodic boundaries in speech, but it is also data taken from TED Talks, which are usually pre-written speeches that are heavily rehearsed and usually delivered by professional speakers, or at least people with a lot of public speaking experience. So it's still not necessarily entirely representative of how we talk when we're just sort of planning on the fly. So our current goal was to use the methods that they had or developed to identify prosodic and syntactic boundaries and apply them to unscripted, spontaneous speech that we've collected in our lab. So over the past couple of years, our lab's been working on a line of research that looks at linearization in language production. And we've run several studies looking at this phenomenon, but we've also, throughout this, been able to collect a large amount of spontaneous speech data. So in this work, we took 4 different data sets that we've collected over the years to use in our analysis. And so the general method for these studies has been to have participants come into the lab and show them these complex visual scenes like the one you can see on the right there. And then people are given 30 seconds to just describe what they see. And so, like I said, we use data from 4 different studies that follow this general method, but of slight variation in the instructions or the participants. So the first data set was sort of the most basic version, where we tested young adult undergraduate participants, and they just came in the lab and were told they would have 30 seconds to describe each scene, and they might produce a description like this: I see a kitchen and a living room, and there's bar stools, and so on. The next study or data set that we used followed the same general procedure, except this time participants were given a deadline that they were told to try and speak before. So they'd hear a beep about 3 to 5 seconds after the scene appeared, and they were instructed to try to start their description before the beep. So this puts a little bit more time pressure on their speech planning. The third data set we used was again from young adults, but in this case, instead of being asked to describe what they saw in the scene, they were asked to produce action descriptions. So essentially saying, what would the average person do in this scene? So they might instead produce something like, if I were in this room, I might turn on the radio, grab a book to read, sit on the couch, and so on. And then the final data set we used was from older adults, where this was just the sort of basic task. They were asked to just come in and describe the scene. So the resulting data set we had to analyze was from 4 different experiments. There were 30 scenes in each experiment, 30 participants in each experiment, and for every scene, they were given 30 seconds to describe it, which means we have about 1,800 minutes, or about 30 hours of recorded, unscripted speech to analyze. And so, again, we followed the same methods that were developed by Degano et al. To identify prosodic and syntactic boundaries. And then we also excluded words that the prosodic toolkit said had a boundary strength of 0, or the word durations were less than 100 milliseconds, just to eliminate words that didn't really provide a lot of acoustic information. So to start looking at the results, in our first step, we also modeled the range of prosodic boundaries for each data set. And as you can see in these, it comes out looking like there's sort of 2 peaks in the distribution, one to represent strong prosodic boundaries and one to represent weak ones. But if you look at just panels C and D for the older adult descriptions or the action descriptions, the skew looks a little bit different. So you can still see the 2 peaks, but they're a bit more attenuated. And this means that the calculated cutoff for strong prosodic boundaries was a little higher in those 2 studies. And then if we go ahead and look at what the alignment looks like between the syntactic and prosodic boundaries, I'm just going to direct your attention to the right side of each of these, because our main hypothesis was that if there's a syntactic boundary, it should also represent a prosodic boundary. And as you can see from these graphs, the alignment doesn't come out very good in these spontaneous descriptions. So for the scene descriptions by the young adults, the 2 on the right side there, the highlighted in green, we do see slightly more alignment of strong and weak boundaries, but it's only about 52-53%. And we did examine the significance using a one-tailed binomial test, which does come out as significant, but I think that's more just because of the volume of data. So each of these bars represents a couple thousand words. But as you can see, we calculated the effect size using Cohen's H for proportional data, and it's extremely small. And then for the older adult descriptions and the action descriptions, we actually see an opposite pattern where there's less alignment of prosodic and syntactic boundaries. And if we compare that back to the data from Degano et al., I just want to highlight the fact that we have actually swapped the axes here. So in our figures, it's clustered by syntactic boundaries on the x-axis, and their original figure was clustered by prosodic boundaries. But if we take their data and flip the axes to look more like ours, you actually see a similar pattern of what we're seeing with the older adults and the action descriptions. So we see at least 50% alignment in the young adult scene descriptions, but not so much with the older adults and the action descriptions. And this could be because of variations in the task instructions or just the participants. But what we really were curious about is why is there just sort of poor alignment across the board? And so one of the challenges with this is that both syntactic boundary strength and prosodic boundary strength are continuous variables, and this approach forces them into binary categories. So the next thing we looked at is what the relationship between syntactic and prosodic boundary strength really looks like. And so in these figures on the x-axis here, this is just the number of syntactic closing nodes, or if it's 1, it just represents a word boundary, and then all the ones above would be identified as syntactic boundaries. And on the y-axis, we have the average prosodic boundary strength calculated for each number of closing nodes based on the output of the prosodic toolkit. And what we did here was test what the relationship between prosodic and syntactic boundary strength looks like by constructing 3 separate models to test the linear, quadratic, and cubic fit of the data. And across all studies, we do see that a cubic fit sort of best explains what this relationship looks like. And this has been seen in other papers as well, such as Kentner et al. In 2023, that also found syntactic and prosodic boundary strength isn't necessarily a linear relationship. But the other challenge with this is that in the first set of plots we showed you, we followed the original paper that identified anything that was beyond a word boundary as representing a syntactic boundary. So I've represented that by this thick line here. It's not 1.5, these are whole numbers on the bottom, but I just put it there to kind of visualize where the split would be between syntactic boundaries. And as you can probably notice, for the ones that are at 1 and 2, the average prosodic boundary strength really doesn't look that different. So this might suggest that we need to sort of consider not just whether or not a syntactic boundary exists, but what the strength of that boundary looks like, and if that leads to a greater likelihood that it'll be marked by a prosodic boundary. So we reanalyzed this by taking a higher cutoff of at least 3 or more closing nodes. And when we plot it this way, you do start to see better alignment of prosodic and syntactic boundaries, especially in the young adult scene descriptions. And for the older adult descriptions and the action descriptions, it does sort of cross that threshold where it's slightly above 50% alignment now, but it's still quite a small effect size for those 2 studies. So the last thing that we looked at in this data was to consider what might be affecting the presence of prosodic boundaries beyond just their relationship to syntactic structure. And to look at this, we looked at the correlations between the average speech rate calculated as words per second and just the average percentage of words in each text that were identified as representing a strong prosodic boundary. And what we see is a strong, some variation in the strengths of the correlations, but overall, a strong negative correlation between how fast people are talking and how often they're producing a prosodic phrase boundary. And so what we think this means is that the presence of prosodic boundaries might be more related to aspects of speech planning, where if we're planning in incremental and temporal units, if you're speaking more slowly, you're sort of planning fewer words at a time and putting in more prosodic boundaries than if you're speaking more quickly and kind of putting more words into each prosodic phrase unit. So overall, in our findings, we see that in unrehearsed scene descriptions, there's generally fairly poor alignment between syntactic and prosodic boundaries, but this relationship between boundary strengths is not linear. And so when we are investigating questions related to how prosodic phrasing aligns with syntactic structure, we need to consider not just the presence of a boundary as a discrete variable, but rather what the strength of those boundaries looks like. And then finally, the negative correlations between speech rate and the average number of prosodic boundaries seems to suggest that prosodic phrasing is not driven just by syntax, but also other elements of speech planning. A couple caveats to this research is that in all of the data sets we have here, it is just people coming into the lab being asked to describe what they see, so it's not an interactive task, whereas most of the language that we produce day to day is in response to another interlocutor or sort of designed for a specific audience. So what we want to look at next is whether this relationship changes depending on whether we're actually having a conversation versus just producing speech. The other things that I want to highlight are that measures of prosody are highly variable, so changes in pitch, duration, intensity kind of vary across the board as we're speaking, and it's difficult to kind of always determine exactly which aspect of prosody is driving these calculations of prosodic boundary strength. And then finally, in all of this data, we were dependent on the automatic parser and how it assigns syntactic structure to our descriptions. And this is important given the sort of massive data set that we had to work with. But these tools are also not always completely perfect in how they're going to parse our data. But overall, we think that this research challenges some of the categorical approaches to prosody, where maybe we don't want to think of prosodic phrases as being these really discrete units, but instead things that vary in intensity or strength, depending on aspects of speech planning and recovery as we're producing spontaneous speech. So thank you very much for listening, and I just want to end off by highlighting the other authors on this work, Fernanda, of course, and then the rest of our lab, Madison, Beverly, Casey, Barb, and Adrian, who have all assisted with data collection and discussion and analyses and so on with this work. So thank you.
Okay, we have about 12 minutes for questions.
Hi, Jessie Snedeker. Very interesting talk, right? With a rich, large data set and an interesting approach. I was trying to think about how to integrate it with everything else that we know about prosody, right? Mm-hmm. And I guess one thing that for me was really interesting was the divergence you got between the action task and the relatively parallel description task, right? And I'm just thinking that an element that was missing, right, here was the other function that prosody serves, which is marking discourse structure containing semantic and pragmatic information, right? As well as the kind of related fact that prosody is going to be constrained by the number of syllables in a given phrase. And it seems like both of those could be really very different in the action task, right? The description task, I'm imagining that you probably mention every object about once, not perfectly, but that's kind of the aim there. And so everything gets its own nice heavy noun phrase. And so a noun phrase is big, a noun phrase gets a break after it. The subject noun phrases are going to be relatively heavy compared to the rest of life, right? Whereas in the action description task, there's all these I's that are popping up in there, and you probably talk about the same object and doing multiple things, so it becomes an it, right? And so I guess I'm wondering, do you have any plans to investigate what makes these different, or to try to bring the pragmatic and the phrase length issues in terms of syllables into this again?
Yeah, absolutely. That's a great question. So that's actually what we've kind of speculated on, why we see difference in the action descriptions versus just the scene descriptions, is that when you're describing sort of just what you see visually in the scene, it is a lot more noun heavy and sort of identifying different objects, whereas if you're describing an action, you need a slightly more complex structure because you're probably going to bring in verbs and their relationship with other objects and so on. So we haven't specifically looked at yet how that kind of linguistic variation affects this alignment, but it is something we're hoping to look at more closely. I think we did kind of do a brief check to just look at, because the parser also identifies like parts of speech, to just look at sort of the average number of nouns produced per description across the different tasks to see if that was maybe driving some of the effects. And we didn't necessarily find a strong relationship between number of nouns and just the prosodic boundaries, but that doesn't, it was kind of a bit of a quick and dirty check. So there's a lot more work to do there to look at how that affects it. Yeah.
Hi, John Triswell, University of Pennsylvania. Great talk, really enjoyed it. I had a sort of more of a methodological question. Can you say a little bit more about the automatic assessment of prosodic strength and what contributes to determining that strength, and then also have there been attempts to sort of validate that from hand coding or something like that?
Yeah, so I'll go back to where it is here. Yeah, so we were using the prosodic wavelet toolkit, which it basically does like a continuous wavelet analysis for each kind of peak in the acoustic signal, and then uses that to continuously extract the F0 duration of it and then the energy of it. And then it uses, I believe we use like a sum function to put those all together to calculate the boundary strength there. So I'd have to look back at the paper. I'm not sure if they've compared it specifically to just having people go in and identify or coding what prosodic boundaries are like. But part of the reason we chose to do this is because it kind of eliminates a little bit of the subjectivity of identifying
I mean,
boundaries.
there are advantages to doing it. You also get a lot more data very quickly. But
Yeah.
it would be, I'm also just curious what they sound like, what they, something that's a strong prosodic break versus a weaker one, and whether that aligns with our own perceptual experience.
Yeah, so it was a little bit varied in terms of even just like myself listening to it, in terms of where I would necessarily say that's a strong boundary versus the calculations. And part of that trouble also comes from this sort of method of just like binarizing it, where it depends on where that cutoff is. I'd be happy, I believe we can, if you're interested, I didn't include it in the presentation, but I believe we can share the recordings if you're interested in kind of hearing what it looks like. Yeah.
Thank you.
Are we still doing the junior people there and senior people here? Okay.
Yeah, John.
I didn't even see someone standing there, so sorry. My peripheral vision.
Well, I'm flattered. I don't really feel very junior. I'm Adam. I'm a postdoc at NYU. What was I going to ask you? I was going to ask about lexical effects, or maybe that's the wrong way of phrasing this, but it might be that some of the syntactic boundaries are clear from, this is sort of a similar question, just maybe more based on context or meaning, and if you've looked at that at all, if maybe you can, attribute some of the low prosodic boundaries, but high, or where you've got big syntactic boundaries to just the fact that maybe it's clear from meaning from the particular words or context.
So do you mean sort of like because the sentence context itself kind of allows people to parse that it wouldn't need a strong
or maybe
prosodic
you've got like a
boundary?
really hard intransitive verb that like cannot take an object, and so it's really clear that that's the end of a phrase versus a verb that takes multiple,
Yeah.
argument frames.
And I think that might be sort of what we're seeing a bit in this analysis here, where like it kind of, the prosodic boundary strength or average boundary strength kind of goes up with syntactic complexity to a point and then seems to like drop off.
Oh,
And it might be the case that as we sort of have stronger boundaries, either because you've got through all of the more complex stuff before it, or because it's sort of a more obvious syntactic boundary that there's not as much need to add like a prosodic
cool.
marking. Is that?
All right, thank you.
Okay, thanks.
Hi, Nicole Holliday, Acting Associate Professor, UC Berkeley. Thank you for this, and I appreciate that you mentioned the sort of issue of making continuous variables categorical. There's a lot of strategies that Anglophones use for prosodic marking, and I think that some of them may have not been captured in the unsupervised training model that the original paper used, and that might be what's contributing to some of the messiness of your data. So they're looking at F0, amplitude, and duration, but there are phrase-final phenomena, such as voice quality rate, creaky voice, and even phrase-final lengthening that might not be accounted for here. I wonder if you've considered, and also you didn't say anything about the participants in your study in the descriptions. I assume that they're white undergraduates, because when people don't say, that's usually what they are. But there still could be variation among that population as well. Individual speakers, even just your standard undergraduates, some are more likely to use duration, some are more likely to use F0. So I wonder if you have considered sort of categorizing your groups of speakers by their performance, by their phrase marking, boundary marking strategies, and then seeing if your model might improve. So you might have actually multiple groups of people that use different strategies to accomplish prosodic boundaries, and that might get you more alignment with their syntactic boundaries.
Yeah, that's a really good point. And yes, it was just a convenient sample of undergraduates from UC Davis. So we haven't sort of teased apart the sort of specific contributions of different elements of prosody, such as duration and so on. But there are sort of differences in just how people approach the task, where some, especially for the scene descriptions, you see differences in people sort of taking almost more of a list-like approach and identifying objects versus people using more complex kind of sentences. And so I would suspect that sort of depending on those strategies, there's also variation in how they're prosodically marking, especially people that are speaking more slowly might be using like lengthening a little bit more and so on. But we haven't specifically considered that yet in the data. Yeah, thank you.
Hi, John Robert Starr, Cornell. Very interesting talk, thank you for sharing. I was wondering if you could talk a little bit more about sort of setup of the experiment and how like maybe you could control for focusing on prosodic boundaries in the beginnings of the utterances, because they are scene descriptions, as some people have already mentioned. They can go on for kind of long, so perhaps the prosodic boundaries are very strong in the beginning because as the planning sort of things you've alluded to, and then perhaps as they go along, they're kind of like, oh, I have more things I have to talk about. There's an apple over there that I completely missed, or something like that. Yeah, and I was wondering if you could talk about like the way that you kind of conducted those analyses, and if there's any biases towards certain positions or not.
Yeah, so I haven't included it here, but I did kind of do a bit of an exploratory analysis looking at the average prosodic boundary strength depending on like word position. And you do see that words that come earlier in the descriptions, on average, at least have higher prosodic boundaries, and it kind of tapers off towards the end, where when you get closer to the end, on average, they're a little bit lower. Yeah.
Cool, thank you.